Alright, so we're on to 2.5, which is the distributive property. It's a very important property that you use many times throughout algebra. Pretty basic concept, and once you get the hang of it, shouldn't be too hard. But this is kind of like, since we've been doing a lot of easier adding and subtracting stuff, this is a little bit more actually using algebra. So, we'll get started. So, the distributive property, and firstly we're going to do it with respect to addition, so we're going to use it involving addition. So it says for all real numbers a, b, and c, so those are all real numbers, and you say that a, and then parentheses, b plus c is the same as ab plus ac. It can also be written as b plus c and then a right here. Again, it's the same thing. The a or the b could be in honestly any order, because we know about the commutative property for multiplication. It doesn't matter which order. Personally, I like this one better. I like putting that a in the front, put that number in the front, so you're not going to typically see me do it there, but it could be in the book or it could be somewhere where you see it. So let's do an example. So we have this, and I take my little arrow, so I'm going to multiply those two first. So we have 13 times x, so we have 13x, and then we do 13 times 2, which is 26. So that is your first answer. So hopefully that was simple enough. So we're going to go, and hopefully you've guessed it, we're going to do the distributive property. Distributive property with respect to subtraction. And basically looking what we had before, it's the same thing, but instead of the addition we have the subtraction. So we're going to say if we have a, where a, b, and c are all, they're all real numbers, so a, b minus c, that's the same as ab minus ac. And again, those are being multiplied if you did not realize that, okay? They're next to each other. And then b minus c times a, and then we have ab minus ac. So, very similar, but we have that subtraction, so we have 4 times x, which is 4x, and then we have the 4 times the negative 6. Make sure you are careful with that sign. So before, if you look back, it was positive, so that's why I said 13 times a positive 2 to get a positive 26. Well, now we have a 4 times a negative 6, which will give us a negative 24. So there you have it. Now, we can use the distribution in reverse to add like terms. I'm going to put like terms in there because that's what we call it. So if you look at this, for instance, 3x plus 5x can be rewritten using the distributive property as x times 3 plus 5, because we know if we multiply it like this, we can write it in any order. We can write x times 3, or we can write it as 3x, and that would be plus 5x, okay? So it's the same thing. But once we have this, we know that we could actually simplify the 3 plus 5 to be 8. We would never write it like that. We would always write it as 8x, but there you have it. So now we almost had like a little proof there, saying that we now know how to simplify like terms, okay? So like terms are terms that can be added or subtracted that have been multiplied by the variables, okay, to the same power. Okay. So let me give you some examples because it probably will make sense. So you have 4y and 8y. They both have just one y there, okay? Like when I say one y, like this one has 4, so that has y and that has a y, okay? So they are like terms. Now here they both have that y, but this one's raised to that second power, so they are not the same. So they are not like terms. And 3a and 3b, although they both have 3's, that doesn't matter. A and b are not the same, so they are not like terms. So when we simplify is do anything you possibly can. So I first can see right here that I can distribute. So I'm going to distribute that 2. So I'm just going to rewrite the 7x. And then I'm going to have 2 times 3, which is 6, and 2 times x, which is 2x. Now, is this simplified? No, because we have the 7x and the 2x, and we know we can combine like terms now. And 7x plus 2x is 9x, 9x plus 6. Can you combine that anymore? I sure can't, because they're not like terms. So this is as simple as we can possibly do. So that is as simplified as we possibly can. Now, this is another one which I'm going to throw in there because so many people mess up their negatives, okay? So, before this, if you look up here, that one was positive, so that's why I was multiplying that positive 2. Well, what if it's negative, okay? Well, and also, where's the number? You can always think of it as a negative 1, okay? Unless there's a number there, obviously, then it would be a negative whatever number that is. But, so I just think of it as a negative 1, okay? So, I'm going to keep 2 the same, and then I'm going to distribute this negative. So it's really like a negative 1 times 4x, which gives you a negative times a positive is a negative, so we have a negative 4x. And then that negative times a negative 3 would give me a positive 3. So now I need to simplify like terms. Now, don't get confused. That negative, we're not saying 2 minus 3. That negative goes with this. If you want to think of it adding a negative, that's fine, okay? But, so we need to add 2 plus 3, which is 5, and then we have minus 4x. Or, again, you could have written it negative 4x plus 5 because of the commutative property. So just be careful with your negatives.